To evaluate this limit, we first look at the absolute value of 2x minus 1 and realize that whatever is inside the absolute value, I mean the quantity 2x minus 1 is negative because as x goes to 1 half from the left, this quantity is going to be like 2 times 1 half from the left minus 1, and that is the same as 1 from the left minus 1, so it will become very close to 0 but from the left, so that quantity is negative, and I can write it as of course the absolute value of 2x minus 1. Since the quantity inside is negative, then I can write that as minus times whatever is inside, and then I will just go and evaluate the limit. Now the limit can be written as the limit as x goes to 1 half from the left. Now we said this quantity, the absolute value, can be written as minus 2x minus 1 divided by x minus half times x cubed. What I'm going to do here is that I will multiply by 2 and also divide by 2. The reason for this is that I could do some simplification, so this quantity is going to, the limit I mean, is going to reduce to the limit as x goes to 1 half from the left minus 2x minus 1 divided by, now if I multiply 2 by this quantity here, I will get 2x minus 1, and as a matter of fact I can use also parentheses. Whatever remains there is just 2x cubed. And you can see that there is a bit of cancellation here. 2x minus 1 will cancel with 2x minus 1 because x is not really 1 half and this quantity is not 0. It's pretty close to 0, but it's not 0. So the limit is going to reduce to the limit as x goes to 1 half from the left of simply minus 2x cubed, which when evaluated will come just as direct substitution of that will give you minus 2 times 1 over 8, and the answer is minus 1 over 4, which is E. For this limit, I will first focus on the quantity e to the 1 over x as x goes to 0. So this quantity e to the 1 over x as x goes to 0 from the left is going to behave like, okay, let's just look at 1 over x first. 1 over x as x goes to 0 from the left is going to be like 1 over 0 from the left, and this is infinity, but it has a negative sign because we come to 0 from the left, so this is behaving like minus infinity. Alright, therefore the quantity e to the 1 over x will behave like e to the minus infinity, which is very much equivalent to this behavior, 1 e to the infinity, and that is of course e to the infinity is infinity, so 1 over infinity is going to go to 0, right? So now we see that this limit is going to behave like 1 over 1 plus 0 as x approaches 0 from the left, and that is going to be 1, and the answer is just A. In this limit I can pass the limit to the argument of the function because the tan inverse is a continuous function. So therefore I can write this limit as tan inverse of the limit as x goes to 0. I can also factor x squared minus 1 into x minus 1 multiplied by x plus 1 divided by x minus 1, and use parentheses here too. There's a bit of cancellation here. X minus 1 will cancel with x minus 1, and the result is the tan inverse of the limit as x goes to 0 of x plus 1 here. Okay, and as x goes to 0, then this is going to reduce to tan inverse of 1, which is equal to pi over 4, and the answer is just B.